Okay, so final project. So I'm going to give a demo on it. I'm basically going to use this data set here, which is a bunch of Airbnb data, to make a data visualization Streamlit like you would in your final project. No one's here, so there won't be anyone interrupting for questions, which would have been nice, but it's okay. So to start, I want to check if my Streamlit's working. So first thing is just going to be, we're going to import Streamlit as ST. All right, and all we're going to do, right, hello world. So when I go down here, to run this, I need to go to the terminal. If I'm already running something in Streamlit, I want to cancel it like that. Okay. So Control C will cancel your Streamlit from running. So now that I'm back here, I can see this tells me what folder I'm in, right? So it says I'm in the fall 21 folder. My scrap file is outside of that. That's just up in Python. So I can go cd ... and get back up. Now I'm in Python. If I was up another level and I was in my source and I wanted to go back down into Python, I'd do cd Python. All right. So now to run Streamlit, I do Streamlit run scrapped up, the name of my Python file. And now that, which you can't see, brings me over to this page, which is a Streamlit thing running hello world. So yeah, we're good to go with Streamlit. Let me go back to the other screen. Okay. So when I'm reading this in, the first thing I want to do is I need to read this data in. I need to open this file and read it in. The thing is, a lot of the final project is pandas. So what we're going to want to do is read this in as a pandas thing. So first thing, we need pandas. All right. So if I'm going to read in this data, all right, I'm going to make a data frame, which is equal to pandas read CSV. And then we're going to plot a course to our scrap file, or our Airbnb, which is in the scrap files folder. So we can go scrap files / Airbnb.csv. Okay. So that's all we got to do. And this should convert this CSV file here into pandas data frame. So when I print df, let's go back to the normal console to run this. Nope, not the console, the whatever, I'll just hit run up here. Yeah, because we need the run tab. So we can see this is all working out nice. So I have this random stuff for the indexing in pandas. So like pandas automatically assigns an index, but we could set the index, right? So we can just do set index. So that way it's the custom one for the file. So now we'll have ID be the index. See, so now we have that over there, and then we have the name, and all these ... represent all the columns in between. So like with this data frame, we can call it similar to other data structures. I want to see the name, right? So let's just do the names. See, now we get the index and we get the name. I want to see the neighborhood, right? So we can call different parts of this data frame this way. So this is how you'll break down and manipulate the data as you go forward. So we might want to call this multiple times. So we're going to put it in a function. We know it works. So we can just put this in read data. There's no arguments here. We want this to happen no matter what, every time we call this function. So we can just have this return data frame like that, or we can just have it all go in one line. So this spits this back out. We can go return pd.read. So right now, if I run this, nothing happens. Okay, but if I run read data, nothing will happen again because it's being read, but we're not doing anything. So if I print this out, we should be able to see our data frame, which we can, okay? So that's the simple part. That's the simple part. Reading in what data you have. So as you go around, you might want to, we might want to filter some data. Let me comment this as a read in data, okay? So now we might want to filter the data, okay? So we can do some stuff with that. So let's set our data frame is going to be equal to read data, okay? Now I can take this data frame and I can manipulate just the things we want to see. So let's say we only want to see some neighborhoods. So what we're going to do is call the location, right? The df.loc, all right? Now, the same way we were calling just the neighborhoods earlier, we want to just pull all the neighborhoods out of this data frame. All right, so now we're going to check if it's in, right, some type of list, right? So in this list, oh wait, we needed to go like this, is in, and then inside these brackets, we put a list. No, wait, yeah. So in this here, we can check, let's just pull some of them. We got the Port, Riverside, and West Cambridge. So we want to see the port capitalization is important here. Riverside, and West Cambridge. We only want to see these neighborhoods. This still didn't print anything. Okay. So now when I print the data frame, we should only see, let's print the data frame with the neighborhood. We should only see these 3 neighborhoods, which we do, okay? So we can do some more filtering, right? We can now take our data frame and go data frame.loc, data frame. We can check the price. If it's less than 180, right? Now we can print our data frame again. Let's print our data frame with a neighborhood, or let's just print it with price. So we shouldn't see any prices that are bigger than 180, which we don't. Perfect. And we can do something else here. We can do, let's filter by availability. 65, okay. Let's also see as long as this is greater than 180. If there's more than 180 days available, all right, then we'll print df. Okay. So, yep, all of these ones are bigger than 180. Okay, so now we want to put this into a function. So we'll call it define filter data, okay. And we're going to need this to return the data frame. Okay. Now our issue here is we don't want these to be, you know, right now this function is static. It'll only do what it'll only filter by these neighborhoods, this price, and this availability. So instead, rather than a list, we'd want a list of like selected neighborhoods. We'd want some type of selected neighborhoods list, but we don't have that yet. So what we can do to combat that is put it up here. We can put selected neighborhoods up here. So that way, when the user on Streamlit enters which neighborhoods they want, once they enter which neighborhoods they want, we can put them into this function to filter the data set that way. So we got to selected neighborhoods. We'd probably want a max price and a minimum availability. Okay. So now now when I run this, or actually, so I forgot. So we need this to be the max price now, and we need this to be minimum availability. So as we test for now, let's just set some defaults up here. Let's just set, you know, our default neighborhoods. It's going to equal West Cambridge, Riverside, and the Port. Okay, so this is our defaults. And then we'll set our default price. It's going to equal 180, and our default availability is going to also equal 180. So now when I run this, okay, I can call our data is equal to filter data. All right, and in here, we're going to want to put our selected neighborhoods, which are our default neighborhoods. Then we want to put our max price, which is our default price, and then our default availability, right? And then we can just print our data. So when I run this, right, we get the same filtered data frame. I can print data of just neighborhoods to double check. And I can print the neighborhood and the price to check again. And these should all be under 180, which they are. All right. So that one is working out well too. So if we're gonna build some graphs now, what we're gonna need is, we're gonna need some more complicated data than just what's already in this file. First thing we might want is like a frequency count, right? We want to, we're gonna want to count the neighborhoods, or count frequency of neighborhoods, okay? So what we need to see here is we first need a list, okay? And in this list, we're gonna get all the neighborhoods. We're gonna get the size of each neighborhood. So your data frame is gonna equal read data. Or actually, we're gonna have our data frame is gonna be equal to filter data. And it's gonna be our defaults, default neighborhoods, default price, and default availability. Okay, so first all we need, we're gonna need to generate a list of all the sizes of each neighborhood that's in this list, okay? So what we're gonna do is we're gonna set our list. It's gonna equal, we're gonna call each neighborhood from the data frame, okay? We're gonna check if it's in the one specific neighborhood, right? And we're gonna call this shape of the index. Shape is like length or like dot size. It gets the size of each data frame list. So we want this to be a list iteration. So we're gonna go for each neighborhood. In the list of neighborhoods. And let's call it our default neighborhoods list for now. No, wait, we need every neighborhood. So, no, sorry. We do need the default neighborhoods. Okay. What is its issue with this? Data frame, dot loc, data frame. There we go. Okay. So now I print this list, right? We should get a bunch of counts. Wonderful. Neighbor, did I spell neighborhood the same way in both? Yeah. Love these. Spelling errors, perfect. Okay. So now we have 19. So we have our list and we have our neighborhoods. So we know that these correspond to each other, which is exactly what we want. So now we could if we want to turn this into, we want to turn this into a function, into a chart. You know, it's given that we have counts, we can probably do a pie chart, right? Because we have each neighborhood in its list. So for a pie chart, you know, we're going to start off with plot figure to erase this. I almost forgot to. We need import matplotlib. Okay, so to do the pie chart here, what we're going to want is to plot the figure. Okay. And then we're going to want to plot.pie, and we're just going to call our list, and our labels are going to equal our default neighborhoods. And then we're going to use this auto percent thing, percent.2f, and that should automatically format what they look like. Okay, so oops, there's an extra percent here. So when I rerun this, okay, so what's its issue here with my keyboard interrupting? Okay, let's just stop. Okay. Now let's run here. Stop and rerun. Okay, so now when we run this, we should see everything pop up, which it does. Let me just share that piece. So now we get this nice little pie chart. If I want to do something cooler with this though, I can explode certain wedges, like bring one off based on if it's the biggest one or not. So in order to do that, I'm going to make another list called explodes. And we're just going to put in, so explodes is going to be a list of how far from the center each little wedge should be. So by default, we're going to set each one to be 0. Okay. Not of the list. We need this to be of, actually, yeah, we can have it as length of list. Okay. And then we need to find the maximum one. Okay. In order to do that, we're just going to find the list index of the maximum of the list. Okay. So to get max automatically, we need numpy. So let's import that next, or we import numpy as numpy, or as np. So now we got numpy, we're getting the maximum of it. I don't need to rerun yet. I don't know why I just tried to do that. Okay. So then, since we're pulling the index, right? Because this, if we didn't do the index, it would just return the max value, but we want its index value. So we can do explodes of the maximum, which is the index, which gets the index, which corresponds to the right offset and explodes. We're just going to set it equal to something, 0.25. Okay. So now when I run this, oh wait, I forgot a part. So we need another argument now. We need to set explode. We need to set the explode argument, which is going to be our explodes list. Okay. So now that should run. So now this is one chart, and we got it nice and completed. you know, we get this, this. Okay, so last piece of this, we'd probably just want like a title. Nope, this is the wrong screen. We'd probably want like a title. So we can do plt.title is going to be market share for neighborhoods. Okay. Market share for neighborhoods. All right. And then what we're going to do is we're going to put a list and we're going to join it to a comma. So this way we can show flexibly all the names that we want. So now when I run this one more time, it doesn't like something. I tried to make another pretty percent sign there. Okay. So now when I go to here, market shows of it automatically gets the neighborhoods that are in here, which is perfect. Okay. Now we need to convert, nope, again, wrong screen. Now we need to convert this into functions. So first part is count the frequency. So let's just call this count neighborhoods. All right. So the arguments we need in here is we need a list of neighborhoods and we need a data frame. Okay. So we'll get all that from here. We don't need to pull this in now because we already have a data frame in the argument. And then instead of our default neighborhoods, we're just going to call this one whatever neighborhood list we put in there. So neighborhoods. Okay. And then we're going to return this list. So then we're just going to return list here. We could also, we don't need to do that, right? We could just do this all in one line. Okay, go in here. And then we need to pie chart, right? So we need a pie chart here. Let's call it generate the pie chart. Generate a pie chart right now. So I'll move all this underneath. Okay, got to change a few things. In here, we need a list and our selected neighborhoods. Actually, we need we should be more specific here. We need accounts and we need our selected neighborhoods. So in length of our counts, in length of our counts now. This should be counts. Explode, and then instead of this, we want it to be the counts. We need the labels to be our selected neighborhoods. Explodes, explodes, and this should be selected neighborhoods. And then the last thing is instead of plot.show, we want to return PLT. Okay. So now we're going to do, so now we're going to test this out. Okay. We're going to go streamlit.pyplot. That should be what we have to do. And what's its major issue here? Let's see that right. Let's see that pyplot. Yeah. Anyway, we're gonna call our generate our pie chart function, and then here we need the counts. To get the counts, we're gonna count the neighborhoods, and our neighborhoods are our default neighborhoods, and our data is gonna be filter the data, right? Based off of our default neighborhoods, our max price, or our default price, and our default availability. Okay. I think that's all the parts we need here. So now when we go to our terminal to test this, well, actually we don't need to. We should be able to just rerun it up on here. So let's always rerun. Nope, it doesn't. It has an issue. I definitely tried to do too much right here. New share, go back to this. Okay. So what's its issue with st.pyplot? Resolved reference. Oh, I never imported Streamlit. I guess I accidentally got rid of that. Okay. Missing one positional argument, selected neighborhoods, and we need count neighborhoods. Okay, so we've counted the neighborhoods, and then we need our selected neighborhoods, which are our default ones. Okay. So now when I go back to this, all right, this is getting too messy. So our data is going to equal filtered data based on our default neighborhoods, our default price, and our default availability. Okay, our counts going to equal our count neighborhoods based on our default neighborhoods and the data. All right, and now we're going to do st.pyplot, our generate pie chart based off our counts and our default neighborhoods. Okay. So now, if I go check to Streamlit, we have our figure on the web browser, which is exactly what we need. Okay. So these are all working out well. We might need, so if we want to build another chart, we want to build, let's say, a bar chart. Just a second. So in order to build a bar chart, we're going to do it based off of the average price in each neighborhood. So the first thing we need is all the prices. So we're going to get all our neighborhood prices. Okay. This argument is going to call for a data frame. All right. And what we need is another list iteration. So we're going to get the price from each row in the data frame. So each row, we're going to call the price column. We need to call index when we do an iteration through data frame, or unless it'll do that by default. And we're going to iterate. Iterate means to loop, basically, over each row in the data frame. Okay, so that gets all the prices. Okay, now we want to convert this into a dictionary. So we're going to call that dict. And we're going to go for each neighborhood in neighborhoods. Oh, I forgot to build our neighborhoods list, which is going to be another list iteration, just like this one, except we're going to call. Except we're going to call the, come on, fix my typo, neighborhood, fix my typo. Neighborhoods, zero neighborhood for each index and row and data frame rows, data rows. Okay, so we're going to go through each neighborhood. Okay, what we're going to do is we're going to make a dictionary of each neighborhood of I. No, wait, for neighborhood and neighborhoods, we need to make a dictionary of each neighborhood and just set it to an empty list. The reason we do this is first, we need to make a dictionary based on the keys. And then in each key, we can append an average. So, or we can get each price. So now we can just return this dictionary. All right. Now we'd want to change this to the averages. All right, so here we're going to call for a dictionary of prices. Okay. And in this, we're going to have another empty dictionary to start. But this time we're going to loop through each key in our dictionary of prices. No, I completely forgot something. Up in this one, we need to now go for I in range, how many prices there are. What we're going to do is neighborhoods. We're going to get each index of this neighborhoods list, and we're going to add the corresponding price. Again, I spelled neighborhoods wrong. We're taking each neighborhood key and adding a price to its value. So now that we have all these prices, we can go through each key. Bit prices, keys, right? And this, actually, let me slow down for a second. So now when I run this function, all right, we need our, let's comment out this. So we have our data, okay? So let's just print our neighborhood prices of our data, okay? So right now, what we have here is a dictionary that has the port and all the prices in it, okay? West Cambridge and all the prices in it, which is exactly what we need. So now when we go to average them, we're going to loop through each key, and each key is the neighborhood. All right. And we're going to take the key and reassign it. And we're going to reassign it to an average, which we can just use numpy for. And we can do of an average of the values already in there. So it's going to replace all the values with np mean 6 prices of key, right? So now let's return this dictionary. All right. So if you can see now, I got to also print neighborhood averages. This needs to be set as something. So I'll call this prices, and this needs to be set to prices here. So now, the same way we got 2 lists before, we have 2 lists now. We can print, sorry, I misspoke there. So in order to do a bar chart, all right, we'd need a list of X values and a list of Y values. So we have those now because we can take our average, we can set this to averages, right? Now we can get our averages. That's our X value. Values, and that's our Y value. So now we have 2 lists here. See, we got our keys and we got our values, X and Y. So let's set these equal to X and Y. So is this, Y equals this. Okay, we can do plot bar. Plot dot show. Plots up bar X and Y. Plot dot, no wait, we need plots dot figure first. And that would be plot dot show. Okay, so now when I run this, we can see we get our pie chart over here. We get our bar chart of the average prices in each neighborhood. Okay. So going back to this, converting this into a function now, we need to, so we're gonna generate a bar chart. Okay. And to generate the bar chart, all we need, I'm pretty sure, is just all we should need is the averages dictionary. So we'll call the dictionary of averages. Okay. So we're going to follow just what we have down here. We're just going to do our plot. We're going to do our new figure. Okay. And then we can copy this stuff, right? We can just go our averages. And plot our figure, plot our bar chart, plot. This will be return PLT. We don't want that stuff though. Instead of averages, this is going to be dictionary of averages, plot bar. We might want to add some other stuff here though. Would be nice. We're going to want to, we can rotate our X ticks. That's 45. We can set a Y label. It's going to be price. X label. It's going to be neighborhoods. And then we can do a title. Title is going to be average listing price for neighborhoods. Join dict averages keys. Right, so we just want all our neighborhoods in the title, and that'll do the same thing we have up there. So we don't need this stuff now. We can call st.pyplot of, we're going to generate our bar chart. Actually, yeah, I do need that stuff. That I deleted. So now we can do st.pyplot, generate bar chart, and in here we put our averages. So when I come over here, let me share, we get our bar chart on the Streamlit, which is again what we would like. Okay, so one more visualization I'll show, and then I'll put them all together. That's coming out this now. The last thing we want to do is generate a map. Generate a map. Okay. This one, what we're going to do is technically kind of limited, so we don't really need anything in here other than a data frame. All right. So all we're calling is a data frame. Once we have that, we're going to need to change the data frame to be the map one. So all we're going to do is filter out everything except the relevant stuff, which is going to be our name, our latitude, and our longitude. That's how it's spelled. Cool. All right. So now we have a data frame for the map. So got to do a couple things. First, we need to set a view state, something called a view state. So we need another thing, PyDeck. Import PyDeck as PDK. This lets us build maps very prettily. So first, our view state. Okay. We're going to make a view state, a PyDeck view state. All right. We need to set our latitude. This is going to be what the view state is it's basically the default view of like what, because automatically Streamlit will load the map of the whole world. So we need to set where we actually want this to show. So we're going to call the map data frames latitude, average. We need the average of that. The longitude is going to equal the maps. This needs to be map df. Map df's longitude map df. Okay. We need this one's mean. Then we're going to set our zoom to equal like 12 or something. You can play around with that number for how much you need to zoom in. That if you're doing something worldwide, this zoom will be like 2. If you're doing something that's like the size of Cambridge, which is what I'm doing, your zoom is going to want to be around like between like 10 and 15. Anyway, so our view state is that. Now we need a layer on this map, and our layer is going to be a scatterplot layer. Plot layer. Okay. The scatterplot layer is going to have the data for it. It's going to be the map data frame. Okay. And then that's the data for it. I need something else though. Oh yeah, I definitely need to get each position. So it's get underscore position is going to be in weird. It's weird. The quotes are like this. Get position is going to be longitude and latitude, like that. And then get radius. We need the radius, and we're going to set the radius to be about 70. This will drastically change based off of the size of your thing. If you're doing something worldwide, you need this to be like 5 million or something. It's got to be massive if you're doing worldwide so you can actually see the dots. So keep that in mind. Now, after the layer, we're going to set a color. Okay. And our color is going to be an RGB value. So this is red, green, blue. Okay. So we need to set values on each of these. Let's put like, you can do 0 between 255. I have no idea what this color is going to look like, but let's put 100 for red, 150 for green, and something else for blue. Let's hype up the blue, and let's hype up the green a bit and drop the red. I don't know, maybe this will make a pretty color. I have no idea. Okay, so we have those 3 things. Now what we need is a tooltip. And the tooltip's going to let us hover over each dot and tell us what it is. So we got our tooltip. Is going to equal. We need to put in some HTML. So we need a listing. We're going to say listing. Then we're going to put in a line break. And then we're going to put in, right after that, we're going to put in the name. Actually, let's put this in bold. We're going to put in the name. HTML listing name. We need to close this tag in HTML. You can like just take this part exactly and just change the proper words, but this is like HTML. So you might remember it from IT 101, you might not. You might remember it from CS 213, you might not. So we got that part. Now we need a style tag. Or style is going to equal background color. And I'm going to set this background color to be steel blue. And then one last piece is just going to be the normal color is going to be, this is the text color. We're going to set the text color to be white. that should get everything that we need. Background color. Okay. I think that, oh, there's one more piece. We need our actual map, right? Our map is going to be, we're going to call the deck from this URL. So our style, this is setting the style for the map. Actually call this like a, let's call this style instead of map. Map style is going to equal, our map style is going to equal map box dot map box. No, it's like this, colon styles slash map box dash light dash v9. Okay. And our initial view state. No, that's why this is not the style. This is the actual map. Okay, I got confused at what I was making there for a second. So our actual map, we got to set our style is going to be equal to, our style is very simply this URL. Okay. And then our initial view state is going to be the view state that we made. It's going to, the layers, everything in the layers, it's going to be a list, and it's just the one layer that we made. What's next after layers? It's going to be colors. I forgot, is it called that? No, we just would go to tooltip. Our tooltip is going to be equal to the tool, no wait, our tool tip is going to equal the tool tip that we set. Get color is 100% in the wrong place. Why did I let it go down to there? Layer, it's gotta be, I forgot though, does it belong in, it absolutely belongs in layer. Okay, so I'll put that back up here with layer. Get color is equal to, we need a parenthesis here. Okay, so let me separate this stuff out so you can see it better. So our view state is gonna be all this, right? Our layer is gonna be these arguments. And then our tooltip, there's no way around that one. And then our map looks like this, okay? And then all we have to do, all we should have to do now is we don't actually return map like we return plots. We can automatically put our pie, we can automatically put it using pie deck chart of map right up there, okay? So now if I just call generate map of our data, I do a new share to Streamlit. This did not rerun. Wonderful. Oh, there we go. Oh, it went away. But we can see our dots. And it made a nice little blue. Okay, so perfect. The only thing that's not working is our tooltip. So I'm gonna have to diagnose that quick. I come back to here. Why is our tooltip off? We have our tooltip listing. What am I doing here wrong? Our tooltip is equal to tooltip HTML listing. We're saying listing break. Do I need a slash here for the break? Maybe break, bold the name, bolding the name, and then our style is equal to a background color, steel blue, and a color of white. So why won't that go? Let me see. What's going on over here? I need to set some type of argument for picking. Don't I? I forgot after, wait. I forgot something, I think. Yeah, so what I'm forgetting is I need to set, this layer. I need another argument here. I need pickable to be equal to true. And this should let me, yeah, okay. So because I enabled that, now when I see some listings in these neighborhoods, I can hover over them and it'll change what's being shown. Okay, so we got all our pieces together. We got all our pieces together now. So now what we're gonna wanna do is we're gonna wanna make a main function. And in this main function, we'll call all the things, all the little pieces, and put them together. So in here, first thing we want to show up is a nice title. So we'll do st.title. We're gonna take our title and it's just gonna be, let's just do something general. It doesn't really matter. Called data visualization with Python. Okay. We'll write. This is the same as printing, except we're writing to Streamlit. We're gonna do welcome to this Airbnb data. We're gonna welcome to this Airbnb data. I have to actually type that, not just say it. Welcome to this Airbnb data. Please, what we want them to do is we want them to be able to pick different options from a sidebar. So open the sidebar to begin. Okay. So then let me, what are we doing here? Let's just get rid of this stuff for now. Okay. So then what we need is a sidebar. We're going to write on the sidebar. Please choose your options to display data. Okay. So that's what we want in the sidebar. So now when let's run this in Streamlit and see. All right, I gotta actually call this main method. Gotta actually, oops, right. We gotta call this main method and we'll see what we got so far. So nothing should be here, which is just great. Can I rerun? Cool, what's going on? I think I gotta like actually delete all that, which is fine. Okay, so now this has updated. So we have a sidebar over here and we have our stuff. So we wanna actually add some widgets here. So let's go back to this. The first thing we want here is, so instead of having these default neighborhoods, we don't want that. What we want is our neighborhoods to come from a list. All right, so what we need to go here is we need to put in the sidebar a multi-select option. And first is going to be the label. The label is going to say, what do we want the label to say? Select a neighborhood, I'm guessing, is pretty straightforward. Okay. Select a neighborhood. There is another function that we need to make. We need to make something to get every function. Then let's put it up. Let's put it up before we count it. All we can do in this one, all we'd have to do this one is we need to read in our data from the data frame. Let's read data, okay? We're just gonna count how many unique neighborhoods there are. We're actually, yeah, we're gonna need a list. We're gonna make a list of neighborhoods. It's gonna be an empty list. And we're gonna loop over, we're gonna iterate over each row as we have done before. Okay, we can't do this in list iteration because we need a conditional. So if the neighborhood is not in the list is going to append row of neighborhood. Okay, so this should get a list of all the neighborhoods. Okay. And I spelled this wrong. Neighborhoods. So now, if we look on our other thing, we can choose some neighborhoods, which is perfect. We can choose multiple ones too. The next thing we'd want is we need a price tool. We need a price tool. I should probably go back to the code. Okay, c.sidebar. Oh wait, first we need to call this something. Max price is going to equal. Let's make this one a slider. We're going to call it max price. And then, so we put the label and then we put a minimum and then we put a maximum. So you can just look at your data to arbitrarily define that. We also will want a minimum availability. Ability. So we can put that in here. A minimum for availability. How many days is that available? 0 to 365, because there's only 365 days in a year. So now what we need is our data, right? And our data is just going to be our filter data functions. Okay, so if we look here, so we see our filter data once selected neighborhoods, a max price, and a minimum availability. So we can do that, right? We can give it now neighborhoods, a maximum price, and a minimum availability. All right, perfect. So now what we want to do is we'd also want we can also pull our data series here because we don't use data for the pie chart. We use a series. So that's just going to be our count neighborhoods, right? And that's going to be the neighborhoods we chose and the data. Okay. So now to make sure that we don't run into errors that could pop up when we, that could pop up if there's no data being selected, we want to make sure that everything has an option. So if neighborhoods is greater than 1 and max price, oh wait, if neighborhoods is greater than 0, everything should be greater than 0. And max price is greater than 0 and minimum availability is greater than 0. Actually, we'll leave these for now. You don't necessarily need the other two though. We're going to put everything. The map of listings. And then we're going to call our map, generator map on the data. Okay, st.write view a pie chart. Okay, and then we can generate, nope, we need st.pieplot, generate pie chart of our series and our neighborhoods. And then st.write view a bar chart, st.pieplot, generate bar chart, and we need our dictionary of averages. So that's neighborhood averages. And then we need our prices, which is neighborhood prices, and that calls data. So that gets everything there. So now I come over here, list if length of, I think that might need to be fixed if length of news and max price and minimum availability. What the hell is that? Okay. Oh wait, I should actually show you guys this. Object. Oh wait, I'm getting an error on the bar chart. Just a second. Why am I calling? Oh, because this is not generate map. This is generate bar chart. Oops. Yeah. Okay. So now we get everything. All right. So let's clear this. Go back to this. Go back to this. Okay. So now, when I go over to here, we should have everything done. So we open it up, and it looks like this. Select neighborhood. So we need a few. Let's put in. Let's grab 4 random ones. Here are 2 on my team. All right, we're going to set our max price around the middle, set our minimum availability around the middle, and now everything pops up. So we get a map of our listings. If I add another thing here, more pop up, which is what we want. Come down to here, our biggest one gets exploded out, the port, West Cambridge area, MIT. And here's our bar chart. So hopefully this helps you in your final project, given that it's an example of doing the final project. And yeah, make sure you watch this all the way through. I know it was super long, but I don't know, it should help a lot. Okay.